Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be discussing 2D sediment best practices. These are some of the hydraulic best practices for 2D sediment models. As you see on the screen here, I'll leave a link to this page in the description of the video. We're going to be going through these four topics right here: hydraulic warm-up period, mesh quality, selecting a time step, and diffusion wave scour pattern. All right, so what I have on the screen now is a very simple terrain layer plus a perimeter for a 2D flow mesh that I've sketched in. That's all I have in my model so far, along with the projection. And let's go ahead and get started. Now, these best practices that I'm going to describe here also apply to purely hydraulic models with no sediment involved. But since sediment models, especially 2D sediment models, are particularly more computationally expensive and sensitive to instabilities, then it's especially true that these best practices are followed when running 2D sediment models. Okay, so let's get started. Here's the first one. It is going to be always use a warm-up period. There's a toggle for warm-up periods in hydraulic analysis as well as sediment. If I go up to the Run menu and then Unsteady Flow Analysis, we have our Unsteady Flow Analysis dialog box right here. If you click on Options and then Computation Options and Tolerances, and then from here click on the 2D Flow Options tab, this is where we toggle on the warm-up period for hydraulic simulations. That it happens to be in line 11, initial conditions time, and this is in hours. So say, for instance, I wanted to say it's a 6-hour warm-up period. I'll just go ahead and type a 6 in right here. Or if I want it to be a 10-hour warm-up period, type in a 10. And then after that, the next row down is initial conditions ramp up factor. This is going to be a value between 0 and 1, typically 0.1. And this is a fraction of the initial conditions time, where the actual hydraulics ramps up to its initial value, such as the initial stage or the initial flow. So for instance, if I'm using a 10-hour warm-up and then the ramp-up fraction is 0.1, then it would be a 1-hour ramp-up period. All right, so we also have a warm-up period with regard to sediment. Yes, if you click on options and then sediment computation options and tolerances right here. All right, here's a different dialog box. You're welcome to enter the number of days for sediment warm-up periods in this dialog box. That's with regard to the concentration, the gradation, and the bathymetry. So go ahead and enter those numbers in right here. I do talk more in depth about this entire sediment computation options and tolerances in my lesson 92 called 2D sediment options and tolerances. I'll leave a link to that video in this video description, and then you can also find that in the playlist. Okay. All right, so using a warm-up is number one. Number two for best practices on 2D sediment flow is mesh quality. Now, as you see here, I already have my 2D flow area perimeter sketched in here. That's why I have perimeter selected. And what I originally was doing was adding a refinement region. So I'll go ahead and show you a refinement region and then how a break line would oftentimes be superior if I wanted to sketch out some detailed areas within my river reach. So here is the river right now. I'm going to go ahead and sketch out a refinement region. And the basis behind this mesh quality is you want your cells to be aligned with the direction of flow. So in this particular river reach, we have the flow. It starts up here at the upstream end flowing west, which happens to be in the direction of the cells. You can see the cells are sort of aligned east-west. And then it starts to curve down and head in the southwest direction, which is no longer in the same direction as these cells are aligned. And then towards the very end of this perimeter, as I've sketched it out, the river is flowing southward, which again is in line with this mesh. Now, what I want to do is create a mesh where the direction of flow is always in the same alignment as the cells. And you're not going to get that by sketching a perimeter or sketching a refinement region. So I'll go ahead and demo the refinement region real quick. Click on Edit, and let me just start making edits here. I'm going to be sketching just along the bank lines because oftentimes you're going to want a smaller cell size where you expect the water to actually be flowing. So I'll double click and then region 1. I'll call this main channel and then click OK. I'm going to go ahead and make some edits. So edit the refinement region properties. I'm going to use a cell size of, we'll say 50 and 50, both in the X and Y direction. Okay. So I'll click OK, and then I also have to enforce, which is this button right here. All right. So now we have smaller cell sizes in the main channel, and I suppose there is some benefit to doing this. However, we're not actually improving the mesh quality such as the direction of flow is consistent with the cells. So you can see the same situation happens here, just smaller cell sizes where we have the cells are in line here when the river's heading due west. When the river's heading southwest, we get away from that ideal alignment. And then towards the end of the reach here in the main channel, we're aligned once again. So I'm going to go ahead and delete that refinement region. So let's see here. Let me just click on edit and then highlight and then click the delete button. And yes, and it's gone. And of course, now my mesh looks all terrible. So let me go ahead and regenerate the mesh real quick. So I'm going to click on perimeter and then edit and then right click, edit 2D area properties, regenerate the mesh. Yes. And okay, so we're back to where we started. Now I'm going to use break lines. So I'm going to click on break lines, sketch a new break line. Now I'm going to sketch along the center line of the river. Let me just go ahead and zoom in here, then pan over, then click, click, and then these are single left clicks. Double click to finish it. I'll call this river center line. All right. Now what I want to do is define the cell size and then enforce. So we're not quite done yet. I'm going to click on the edit tool right here and then select that center line, right click, edit break line properties. So just as before, I'm going to use a 50-foot cell spacing between the computation points. Near repeats, this is how many times does that 50 cell spacing repeat on each side of the break line. So let's go with 2. I'd say 1 or 2, but let's see what 2 looks like and then click OK. Now for that to actually be enforced and like update the mesh, I need to click on enforce, which is this right here. And boom, this is what we're looking for. So now you can see that the cells are aligned with the direction of flow, especially when the flow is sort of going diagonal to the north, south, east, west cardinal coordinate directions. So when the flow is heading in the southwest direction, the cell mesh is aligned with the direction of flow. All right, so that's just something else to try if your 2D sediment model is not hitting stability or there's some other inaccuracies that you're noticing. But this is also a good tip if you don't have sediment at all, is to align your mesh with the direction of flow. All right, as far as mesh quality goes, the user manual also mentions a couple other things, such as you want to reduce small cell faces and reduce any areas with missing computation points. So I'm going to toggle on the computation points right now and take a look at my mesh. Okay, so it's kind of hard for me to tell if there's any missing computation points at all. Perhaps if I toggle off the terrain and also toggle off the perimeter and the break lines. Okay, well, anyway, let me go ahead and show you the example from the user's manual. So right here, I don't know if you can see it or not, but there is some regions that have this purple outline, ellipse, I suppose it's an ellipse, that shows certain regions within this mesh that are missing computation points. And that's for some reason caused by generating a mesh and then regenerating a mesh. So just be careful with that. If you need to add additional computation points, just click on computation point tool and then click on add new feature. Then I can go ahead and click additional computation points that way. Also, if you notice that your computation point is red, that means there's more than 8 neighboring cells, in which case you need to modify that cell so that it has 8 most neighboring cells. And then the example of small cell faces, let me go ahead and show you that here. So here is what it's talking about. Circled in red here, we have a small cell face. So if you can eliminate the situation where you have a small cell face, and hopefully these intersections could just be like a cross, so 4 neighbors, and then again at this intersection, that is better and would improve the stability and overall performance of a 2D flow model when using sediment. The third topic here is Timestep. The user manual mentions Timestep as a way to improve your model quality and also reduce the time it takes to compute. If you go up to the run menu and then unsteady flow analysis, your computational time interval right here is set. The current default value is 1 minute for me. This may be too large or too small. So one way to rectify this situation and find a good time step for the entire duration of your simulation is to go up to options and then computation options and tolerances. There's a tab here called Advanced Time Step Control. And as you see, the default of fixed time step is selected. So this 1 minute right here is the same as the 1 minute that we have selected here. However, there's a couple of other options, such as to adjust the time step based on the Courant number or based on a time step divisor. So go ahead and check out both of those methods. I describe how they work in detail in my exercise 25 Courant number and advanced time step controls, and I'll run through a whole example here. Generally speaking, you want to set the Courant number to maximum of 1 or perhaps even less than that. And what's going to happen is you don't have a constant time step for the entire simulation, but rather the time step is going to double or half a certain number of times so that your Courant number is within this minimum and maximum range. So for instance, if your maximum was 1, and then your minimum would be, it'd have to be less than half, so maybe something like 0.4. If half of 1 is 0.5, something like 0.4. And then there's different criteria that you give to HEC RAS to tell it when it should double and when it should half. So go ahead and check out that HEC RAS exercise 25. I'll leave a link to that exercise in the description of this video. I just don't want to be talking about the same thing multiple times. But yeah, using the adjust time based on Courant number is definitely a way to improve your model accuracy and even improve the computation time. All right, the fourth and final tip here is to use the shallow water equation set. So let me go ahead and click OK. What I'm talking about here is if you go up to options and then computation options and tolerances, and then if you click on the 2D flow options, we were just here earlier. Now, number 10 here is equation set. By the way, the numbers here are for version 6.6. Later versions of or earlier versions of the software may have different numbering and perhaps different labels. So just kind of be careful with that. But what I'm looking for here is diffusion wave. This is the default equation set, and it doesn't really work that well with 2D sediment. Best practices mentioned in the user's manual is to use one of these SWE methods, shallow water equation, ELM, EM, or LIA. ELM is a little bit faster than EM, I read. But if you're using EM, for instance, you can't have a Courant number greater than 1. So there's some details there. Whereas ELM, I believe you can still go a little bit above 1. So just be careful with that. But I would just say don't use a diffusion wave, which is the default equation set when running 2D sediment models, because diffusion wave will erode the center of the channel and deposit on the sides of the main channel, which has yielded non-credible results. The 2D sediment transport model should be run with the shallow water equations, which we demonstrated is one of the 3 right here. All right, well, that is it for this lesson. We talked about a few different tips and tricks or best practices for your 2D sediment model in HEC RAS.